Hello friends, in this video we are going to discuss about the mixed design of M45 grade concrete as per IS-456-2000 and IS-10262-2019. We are going to calculate the target strength, water cement ratio, water content, cement content, aggregate proportion between coarse aggregate and fine aggregate, and finally the mix calculation. So without further delay, let's begin now. Before starting the calculation, let's look into the required data. Grade designation is M45. Type of cement and grade of cement is OPC-53 grade. Maximum nominal size of aggregate is 20 mm. Exposure condition is severe, that is given in IS-456 table 3. And according to that exposure condition, we can take the water cement ratio and cement content. Minimum cement content is 320 kg per meter cube. As I have told you before, according to the exposure condition, the minimum cement content which we need to take is 320 kg per meter cube as per IS-456 table 5. And then workability in terms of the slump, that is 100 mm as per IS-456 class number 7.1. Transportation time is 30 minutes. Next, method of placing, that is pumping. Standard deviation is 5 Newton per millimeter squared as per IS-10262. Type of coarse aggregate is crushed angular aggregate. Maximum cement content is 450 kg per meter cube as per IS-456 class number 8.2.4.2. Fine aggregate is zone 2. Next, let's look into the test data of material. Specific gravity of cement is 3.16. Specific gravity of fine aggregate is 2.46. Specific gravity of coarse aggregate is 2.73. Specific gravity of water is 1. Admixture type is super plasticizer. Now, let's look into the steps involved in mixed design. First, we need to find out the target mean strength according to IS-10262-2019, and then we need to find out the water cement ratio. And with that water cement ratio, we need to find out the water content, then we need to find out the cement content, and then aggregate proportion between coarse aggregate and fine aggregate, and finally we can do the mix calculation. First, let's start with the target strength. To calculate this target strength, this is the formula: F dash CK is equal to FCK plus 1.65S or FCK plus X. So among these two, whichever is higher, that we need to consider as the target mean strength. F dash CK is target mean compressive strength at 28 days, and S is standard deviation. We need to use the code IS-10262-2019 table 2, which is given in page number 3. In the code, the formula is given in class number 4.2, target strength for mixed proportion. This formula we have seen already. F dash CK is equal to FCK plus 1.65S and F dash CK is equal to FCK plus X. So among these two, whichever is higher, that we need to consider. So in table 1, the value of X is given. For M45 grade, the value of X is 6.5, and from table 2 we can take out the standard deviation value. So here grade of concrete and standard deviation is given. So for M45 grade, we need to consider the standard deviation as 5 Newton per millimeter square. So with these two values, we need to find out the target mean strength. Standard deviation is 5 Newton per millimeter square as per table 2, and X value is considered as per table 1 that we have seen in the code, that is 6.5 Newton per millimeter square for M45 grade of concrete. So now we can find out the F dash CK, that is FCK plus 1.65 multiplied by the standard deviation. So we get 53.25 Newton per millimeter squared. Next, we need to calculate by using this formula FCK plus X. So that comes around 51.5 Newton per millimeter squared. So among these two, whichever is higher, that we need to consider. So the higher value is 53.25 Newton per millimeter square. So this is our target strength at 28 days. Next, let's look into water cement ratio. Exposure condition is severe as per IS-456-2000 table 3 and 5, page number 20 it is given. In table 3, different environmental condition and exposure conditions are given. So we have the condition as severe. Concrete surfaces exposed to severe rain, alternate wetting and drying, or occasional freezing while wet or severe condensation. So this is the exposure condition, and let's look into the water cement ratio for this severe environmental condition that is given in table 5. Minimum cement content, maximum water cement ratio and minimum grade of concrete for different exposures with nominal weight aggregate of 20 mm, nominal maximum size. So here the condition given as severe. So for severe condition, here we have plain concrete and reinforced concrete. We need to look into the reinforced concrete. So for severe condition, the maximum water cement ratio is 0.45. This we need to consider for severe condition. And minimum cement content is 320 kg per meter cube. And then minimum grade of concrete M30. Anyway, we are using here M45 grade, which is more than the minimum grade of concrete. Water cement ratio is 0.45 and cement content is 320 kg per meter cube. As we have seen in IS-456-2000 table 3 and 5, water cement ratio is 0.45 and this can be reduced. This water cement ratio can be reduced since we use the admixture. So water cement ratio we can reduce by 0.05. This I'll explain you later. So we need to consider the water cement ratio as 0.4. Next, we need to calculate the water content. As per IS-10262 table 4 page number 5, for 20 mm size aggregate we have 186 kg, that is for 50 mm slump. Let's check in that code. In table 4, water content per cubic meter of concrete for nominal maximum size of aggregate is given. So here we have the 20 mm aggregate. Water content is 186 kg. Here in class number 5.3, selection of water content and admixture content is given. The quantity of mixing water per unit volume of concrete may be determined from table 4. The water content in table 4 is for angular coarse aggregate and for 50 mm slump. So whatever the water content given in table 4, that is for 50 mm slump. And here it is given as for the desired workability other than 50 mm slump, because we will be having different slump. For example, in our case we have 100 mm slump, even we will be having 125 mm slump. So according to the slump we need to adjust the water content. So for the desired workability other than 50 mm slump, the required water content may be increased or decreased by about 3% for each increase or decrease of 25 mm slump, or may be established by trial. So this you have to understand very clearly. So for 50 mm slump we need to use the water content as 186 kg. Suppose if we have 75 mm slump, then we need to increase this 186 kg by 3%. See, here it is given as the required water content may be increased or decreased by about 3% for each increase or decrease of 25 mm slump. So here 50 mm is the required slump, but we have 25 mm extra. 50 plus 25, 75. So each 25 mm increase or decrease, we need to increase or decrease the water content by 3%. So here we have the increase in slump, so we need to increase the water content by 3%. If you are having 100 mm slump, then you have to increase the water content by 6%. If you have 100 mm slump, then you have to increase the water content by 6%. So in this way we have to keep on increasing the water content. If you have 125 mm slump, then you have to increase the water content by 9%. So for each 25 mm increase, you have to increase the 3%. We have 100 mm slump, so for every 25 mm we need to increase 3% as per IS-10262 class number 5.3. So for 50 mm extra we need to add 6%, because the required slump is 50 mm, we have 100 mm slump, so 50 mm extra we have. So for that we need to additionally add 3% plus 3%, that is 6% we need to add. So 186 plus 6% of 186 is 197 kg. So for super plasticizer we can reduce the water content up to 20%. That is also given in code. Here you can see water reducing admixture or super plasticizing admixture usually decrease water content by 5 to 10% and 20 to 30% and above respectively at appropriate dosages. So for super plasticizing admixtures we can reduce 20 to 30%. From this water content, we can reduce 20%. 197 minus 20% of 197. So we get 157.6 kg. So water content is 157.6 kg after reducing the 20% for superplasticizer admixture. If we consider in liter, it is 157.6 liters. Next, we need to calculate the cement content. Water cement ratio is equal to water content divided by cement content. We know the water cement ratio and the water content. So from that we can find out the cement content. Cement content is equal to water content divided by water cement ratio. You know, water content is 157.6 kg and water cement ratio is 0.4. From this we can find out the cement content. That comes around 394 kg per meter cube, which is greater than the minimum required cement content as per IS-456 table 5 that we have seen before. The minimum required cement content for severe exposure condition is 320 kg per meter cube. So the value we got is 394 kg per meter cube, which is greater than 320 kg per meter cube. So we need to consider the cement content as 394 kg per meter cube. Next step is aggregate proportion between coarse aggregate and fine aggregate. So we need to find out the aggregate proportions. So for that we need to use the code IS-10262 table 5, class number 5.5.1. In the table it is given as for zone 2 the value is 0.62, that is the aggregate proportion is 0.62 for water cement ratio of 0.5. We need to calculate the proportion according to our water cement ratio. So for every 0.05 decrease we need to increase 0.01. That means the given ratio proportion is for water cement ratio of 0.5. So from this 0.5 our water cement ratio is decreased or increased, that we need to check. If it is decreased then we need to increase by 0.01. If it is increased we need to decrease by 0.01. Let's look into the code. In table 5, volume of coarse aggregate per unit volume of total aggregate for different zones of fine aggregate for water cement or water cementinous material ratio of 0.5 is given. So whatever the proportion is given in this table, that is for water cement ratio of 0.5. Since we have the aggregate size as 20 mm and zone 2, we need to consider the value as 0.62, the proportion value as 0.62. Let's look into the class 5.5.1, estimation of coarse aggregate proportion. Approximate values for this aggregate volume are given in table 5 for a water cement or water cementinous material ratio of 0.5. So that may be suitably adjusted for other ratios, because we will not be getting the water cement ratio of 0.5 in all the mixed proportions. So according to the ratio we need to adjust this proportion. So the proportion of volume of coarse aggregate to that of total aggregate is increased at the rate of 0.01 for every decrease in water cement or cementinous material ratio by 0.05 and decreased at the rate of 0.01 for every increase in water cement ratio by 0.05. This looks little confusing. Let me explain you here. The proportion value is given for 0.5 water cement ratio. For example, if you having the water cement ratio of 0.45, so look at the difference between these two, that is 0.05, right? So one time it is decreased, one decrease of 0.05. So here it is given as the proportion of volume of coarse aggregate to that of aggregate is increased at the rate of 0.01 for every decrease in water cement or cementinous materials ratio by 0.05. So here it is decreased 1 times 0.05. We have the value as proportion value as 0.62 plus 0.01, because here the water cement ratio difference is 0.05. So for each 0.05 decrease we need to increase the proportion by 0.01. In case if you get the difference is 0.1, then you have to increase this proportion by 2 times, 0.62 plus 0.01 plus 0.01. I hope you understand. If the difference between water cement ratio is 1 time 0.05, then we need to increase it by 0.01. So this is one condition, and another one is we need to decrease at the rate of 0.01 for every increase in water cement ratio by 0.05. That means Here the given water cement ratio is 0.5. For example, if we have the water cement ratio of 0.55, then you can see the water cement ratio, our water cement ratio is increased. So in that case, we need to decrease the proportion by 0.01. Instead of adding here, we need to decrease 0.01 from this proportion. Here, let's see, for every 0.05 decrease, we need to increase 0.01. Water cement ratio is 0.4. We have the water cement ratio value is 0.4, and then if we see the difference 0.5 minus 0.4 divided by 0.05, we get 2. So 2 times we need to increase by 0.01 with this aggregate proportion, because the difference between these two is 0.05 plus 0.05. Find 1 is the difference, so that's why we need to increase the proportion by 2 times. So initially, while calculating the water cement ratio, for adding admixture, that is why I have reduced 0.05, 0.62 plus 0.01 plus 0.01. So we get 0.64. Here we are using the pumpable concrete. So the coarse aggregate can be reduced up to 10%. That is also given in IS-10262 in class number 5.5.2 for more workable concrete mixes, which is sometimes required when placement is by pump or when the concrete is required to be worked around congested reinforcing steel. It may be desirable to reduce the estimated coarse aggregate content determined using table 5 up to 10%. So if we are using pumpable concrete, the proportion which is given in table 5 can be reduced up to 10%. Volume of coarse aggregate is equal to this proportion minus 10% of this proportion. So we get 0.576 as the volume of coarse aggregate. From this we need to find out the volume of fine aggregate. Volume of fine aggregate is equal to 1 minus volume of coarse aggregate. So we get 0.424. The last step is mix calculation per unit volume of concrete. So volume of concrete is 1 meter cube. Volume of cement we need to find out. Volume of cement is equal to mass of cement divided by mass density. We know mass of cement is the quantity, whatever the cement content we have calculated, that is 394 kg per meter cube, divided by mass density is specific gravity of cement multiplied by 1000. We get 0.124 meter cube. Next we need to find out volume of water. Mass of water divided by mass density. Know the mass of water we have calculated as 157.6 kg divided by mass density. We get 0.1576 meter cube. Next let's find out volume of admixture. Mass of admixture divided by mass density. This mass of admixture we can consider 1.1% of cement weight. So we know cement content volume is 394 kg per meter cube. So 1.1% of 394 we can consider. Mass density is 1.12 multiplied by 1000. So that comes around 0.00386 meter cube. Next one is volume of all in aggregate. So that we need to calculate like this. 1 minus B plus C plus D. B is volume of cement content, volume of water content plus volume of admixture. So we need to deduct all these volumes from volume of all in aggregate. So 1 minus 0.124, this is the volume of cement content, and then volume of water 0.1576, volume of admixture. So we get 0.715. So this is volume of all in aggregate. Next we need to find out mass of coarse aggregate. Volume of all in aggregate multiplied by volume of coarse aggregate multiplied by specific gravity of coarse aggregate multiplied by 1000. So volume of all in aggregate is 0.715 multiplied by volume of coarse aggregate is 0.576 multiplied by specific gravity of coarse aggregate is 2.73 multiplied by 1000, which is equal to 1124 kg. Next one is mass of fine aggregate we need to calculate. Volume of all in aggregate multiplied by volume of fine aggregate multiplied by specific gravity of fine aggregate multiplied by 1000. You know, volume of all in aggregate is 0.715, volume of fine aggregate is 0.424, specific gravity of fine aggregate is 2.46 multiplied by 1000. We get 746 kg as mass of fine aggregate. We have calculated all the volumes. Now let's look into the summary. Cement is 394 kg per meter cube. Water is 157.6 kg per meter cube. Fine aggregate is 746 kg per meter cube. Coarse aggregate is 1124 kg per meter cube. In this, we can consider 20 mm aggregate 60% and 10 mm aggregate 40%. Admixture is 4.33 kg per meter cube, that is 1.1% of cement, whatever we have assumed. So aggregate content is 1.1% of this value. Next one is water cement ratio, that is 0.40. This is the mixed proportion. Cement is 394, fine aggregate 746, coarse aggregate 1124, water is 157.6. So if we calculate the mixed proportion, you get 1 is to 1.89 is to 2.85 and water cement ratio is 0.4. So friends, I hope you all like this video. Please do comment in the comment box. Your comments are always welcome. Also share this video with your friends. We are putting so much effort to create this kind of videos. If you really like the content and if you want to support the channel, super thanks button has been enabled in our channel. Log into your account and then below this video there will be a button called super thanks. If you click on that, you can pay some minimum amount and support this channel. Also don't forget to subscribe this channel for more videos. Thank you for watching.